Hello, it's my pleasure to explain this visual abstract of impact of nano-sized silicon carbide and graphite on mechanical properties of aerospace grade aluminum 7075 composites. In this paper, aluminum 7075 has been used as a base material and two different reinforcements such as nano-sized silicon carbide and graphite has been used as a reinforcement, and this reinforcement has been varied up to 3%. Here, stir casting process has been used for the fabrication of hybrid Metal Matrix composites. The microstructure study, tensile strength, and compression strength of the developed hybrid Metal Matrix composites have been analyzed and examined. It is found that reinforcements are evenly distributed in the base material. The porosity and density of the developed composites are found to be enhanced. The mechanical properties of the developed MMC could be improved by addition of SiC particulates compared to base material. Further, the strength of the developed Metal Matrix composites was found to be decreased by addition of solid lubricants such as graphite particulates. The figure shows the microstructure study of base material and hybrid Metal Matrix composites. From the figure, it is observed that the grains around the hard reinforcement is much finer when compared to the grains around the reinforcement free matrix alloy. So, hard particulates can induce the recrystallization of aluminum alloy by accelerating the particulates nucleation among the matrix and reinforcement phases. The figure shows the effect of density and porosity for the base material and developed hybrid Metal Matrix composites. From the outcomes, it is observed that the enhancement of density and porosity is generally due to the existence of denser particulates in the developed hybrid Metal Matrix composites. The figure shows the tensile strength of base material and developed hybrid Metal Matrix composites. From the figure, it is observed that tensile strength has been increased by increasing the weight percentage of silicon carbide. Generally, this is because of resistance of dislocation, and hence the MMC strength was enhanced by increasing the content of ceramic particulates. Further, the tensile strength has been decreased by increasing the graphite content. This is generally because of several mechanisms such as crack propagation and the particulates pull out, which is instigated by the existence of solid lubricant particulates. Figure shows the same image of the fractured surface of tensile test samples of base material and hybrid Metal Matrix composites. From the fractography study, it is observed that increase in the weight percentage of silicon carbide and graphite content changed the kind of failure from ductile to brittle. Generally, this could be clearly observed from the deformed regions and dimples present within the fractured area. Figure shows the compressive strength of the base material and developed hybrid Metal Matrix composites. From the outcome, it is observed that compressive strength has been increased by increasing the weight percentage of reinforcement, generally due to the presence of hard ceramic particulates. Further, the compressive strength has been decreased by increasing the weight percentage of graphite, because generally this graphite is a solid lubricant which impacts on the negative results of the strength. Conclusions. Uniform distribution of reinforcement within the matrix was observed through microstructural study. Mechanical properties of hybrid Metal Matrix composite increased with addition of silicon carbide content. But further, increase in the graphite content, decreases of mechanical strength was observed. It is confirmed that by increasing the dislocation of density, the strength of composites can be improved. The reduction of mechanical strength observed while increasing the graphite particulates is due to high porosity and interfacial debonding of hybrid Metal Matrix composites. Fracture mechanisms shown in the same pictures indicates higher size of dimples in the base alloy, and dimple size decreased by adding of silicon carbide and graphite particulates. Reduced dimple size is due to the grain refinement.